Hello, my name is Walter Unglaub, and this is Physics of Rear-End Collisions. When considering rear-end collisions, we want to appeal to the law of conservation of linear momentum, which states that the sum of momenta in one instance, in one scenario, is equal to the sum of the final momenta after the collision process. So if we consider a car weighing 2 tons, so mass 1 for car 1 is 2 tons, and it's traveling at a velocity of 50 meters per second into another car, car 2, which let's say it has a mass of 1 ton, and it's traveling at a velocity equal to 20 meters per second. The collision takes place, and if it's an inelastic collision, then we have car 1 smashed into car 2, and this total object will be traveling at some velocity v3, and it will have a total mass equal to m1 plus m2. Now, if we have conservation of linear momentum, we know that the momentum of car 1, m1v1, plus the momentum of car 2, m2v2, has to be equal to the momentum of the final object, meaning car 1 smashed into car 2, which is going to be equal to m1 plus m2 times v3. We can solve for this final velocity by just dividing both sides by the total mass of the cars. So now we have an equation for the final velocity of this collision, and when we stick in these numbers, we get a final velocity of 2 tons times 50 meters per second plus 1 ton times 20 meters per second, all divided by 1 plus 2 tons, which is 3. So this is going to be equal to 100 plus 20 divided by 3. So the final velocity will be equal to 40 meters per second of this collision right here. And here we have utilized the principle of conservation of linear momentum. My name is Walter Unglaub, and this is Physics of Rear-End Collisions.